Hey everyone, welcome to this lecture. In this lecture, we'll be talking about Geopandas. So this is a library that supports geographic data as pandas object. So it's similar to pandas tabular data frame, but within Geopandas, we save spatial data as geoseries and geodata frame. You can further go to this GitHub repo to learn how GeoPandas work. And the main difference between Pandas data frame and GeoPandas geodata frame is that within the geodata frame, we have a geometry column. And this geometry column stores spatial information as one or multiple coordinate pairs. To get started, we'll first import the Pandas and GeoPandas library. And in this particular lecture, we'll be heavily using different types of administrative boundaries. For example, state, county, census tract, block groups, and these administrative boundaries are often organized as with their FIPS code. So these are the unique identifiers referring to different state, county, tract, and block group. The state FIPS codes are usually 2-digit. The county FIPS code are 3-digit, the tract FIPS code are 6-digit, and the block group are 4-digit. And by concatenating all of these various levels of FIPS code, we get the geo ID, which is the unique identifier number referring to each of these administrative boundaries. And this geo ID is very commonly used by US Census Bureau to track and organize their data sets. And here, so we will be using this .read file function to first read the geospatial data. This is a GeoPandas function, and this function can read data in various file formats. For example, shapefile, GeoJSON, GeoPackage. For this particular case, we'll be using a shapefile, and we will be directly loading and reading that shapefile from TigerLine shapefile page. So TigerLine shapefile is managed by US Census Bureau, contains information about about different administrative boundaries that can be census tracts, block groups, state level boundaries, and all that. So here, for this particular case, we are extracting the census tract boundaries for Virginia using this link. So here, this 51 refers to the Virginia FIPS code. And we are saying, okay, extract this tract level information and use the TigerLine shapefile 2022 data. You can manipulate this link as well to extract information for further other states or like other administrative levels, for example, block groups, states, and all that. Now, to make sure that we correctly downloaded the data, we can use this basic single color plot. So here you can see what we just downloaded, all the tract boundaries for the Virginia. And as I mentioned, that the main difference between pandas and geopandas is the presence of the geometry column within the geopanda data frame. So here, this is what we just downloaded, and you can see there's a geometry column, and given its the track level boundaries, they are saved as polygons. Now, we can with this geodata frame, we can just perform all standard pandas function as normal. For example, we can use this .head function to see the first 5 rows of the data set. We can use .shape to extract the size of rows and columns of this data set. For example, in this case, you can see that we have 2,198 rows. That means this many census tracts and 13 columns. And here you can also see the state FIPS, which is 51 for all case, the county FIPS, and also we have the tract FIPS information, and together they're making the GeoID information. Now, GeoPandas is really good at storing the coordinate reference system as an attribute when loading the spatial objects. And we can also like transform this coordinate reference system to another using this .to_CRS function. There are two main types of coordinate reference system we use with geospatial data. The first one is a geographic coordinate system. So Within geographic coordinate system, we consider the Earth as a spherical or ellipsoidal model, and we refer to any location on Earth using latitude and longitude. And we measure this latitude and longitude in degree, minutes, and seconds. A very common example of GCS is World Geodetic System. It's very commonly used for all the like commonly known popular mapping platform. Next, we have the projected coordinate system. So this projected coordinate system transforms the 3D surface of the Earth onto a 2D flat plane and then measure the locations using Cartesian coordinates or like XY grid format. And within projected coordinate system, we refer to each locations and measure its locations in linear unit, for example, meters and feet. And here's you can see some example, for example, universal transverse marketer and WGS 84 pseudo marketer. So these are commonly used projected coordinate system. And with this GeoPanda, we refer to each of these GCS or PCS based on their EPSG number. So for WGS 84, the EPSG number is 4326. And for the pseudo marketer, the EPSG number is 3857. There are many other types of CRS, each more appropriate for different geographic regions and also like designed for those particular locations. So for example, both WGS 84 and also there's another GCS named North American Datum of 1983. They're both geographic coordinate system, but NAD 83 is more appropriate for United States and it can minimize the errors in mapping and positioning within North America. So that's why the title line shape files for all United States, they are stored in NAD 83 and you can use this .crs function to see the current coordinate system of the geodata frame. And like once you run this code, you can see it says, okay, the lat long is in degree and we are using the North American datum and we are using the ellipsoid GRS 1980. Now, with GeoPandas, as I mentioned, you can convert the coordinate system to a different coordinate system. So for example, in this case, I want to convert it to a projected coordinate system so that I can measure the locations in meters. And here you can use this 2CRS function and inside the parentheses, as I mentioned, you put this EPSG number. So for this projected coordinate system, we are using EPSG 3857. Now we can easily find the area of geometry polygons once it's converted to the projected coordinate system and we are measuring the locations in linear units such as meter. However, like if we calculate the area in meters, the number is going to be too big. So we can make some conversion and calculate the area in square kilometers. And here you can see that after creating this new column named area kilometer square and estimating the area in square kilometer, it was added to this data frame. Next, we can extract census data to obtain additional socioeconomic or demographic information about the census tract. And this census data is available in various forms. It can be decennial survey, American Community Survey, 5 years, 1 years. For this particular case, we'll focus on American Community Survey 5 years data set. And here, again, using the FIPS code, you can identify census data for any regions within the data set and modify accordingly. To get the data directly within Colab, you need to install this census library so it's not already installed. And we need to use this code to install the library. And then you can just load the library within the Colab environment. Now, you need to set an API key for this census library to function. You can just go to this link and then provide your organization name and email address. They will give you an API key. It's entirely free. And once you have that, you can put that API key within this codes. So like remove this part and put your API key here. Next, to extract the information, you need to decide what level of information you want. It can be like state level information, county, tract level information. And then you also decide what variables you want to use. There are like hundreds of variables within census data and they are all coded. So you can go to this link to learn about the codes and what does each of those code represent, and then decide like which variables you want. And here in this particular case, so I'm using this three codes that represent total population, total male population, and total female population. And I'm extracting the information for Virginia. So that's why I provided the FIPS code 51, but representing Virginia. And I'm getting information for all county and tract FIPS. So I'm saying like extract information all county and all tract as by providing this asterisk sign. And also we are saying that we want the data for year 2022. You can also manipulate this function, like instead of this tract, you can get block group data or county level data. So all of those functions are mentioned in this link. You can just go here and check out like what other options you have. The data will be returned as a list of dictionary format. And here you can see what I received after running this code. And then we can just convert it to a pandas data frame using the following code. You just call the pandas library, then .data frame, and within the parentheses, you put the dictionary name here. And then you can see it's converted. So first we have names referring to all the census tracts in Virginia, and then the population, male population and female population information. And also these ones are the state FIPS, county FIPS, and tract FIPS. Now you can rename these variable names to make it more self-explanatory. You can use this dot rename function and then just say which columns you want to be renamed. So the first one represent the old column name and the second one represent the new column name. Now we have two types of data right now. So we have these tract boundaries as a geodata frame, and we also have the census data as a pandas data frame. Now we can merge them together. So this merging can be done in between pandas and geopandas data frame, between two pandas data frame, or between two geopandas data frame. And for that purpose, we use this merge function from pandas library. But to perform this merging, you need to have one or more common keys or the column names that is common within both data set. So their data types has to be common so that based on those keys, we can merge these two data set. And also you need to set like how the parameters will be joined. If you say like you want to do a left join, that means like all the information on the left side data, like all of its rows will be retained. If you do a right join, then all information on the right side data, all of its rows will be retained. If it's an inner join, then we will only keep the key values common in both dataset. You can see and learn more in detail by going to this link. And to identify the column keys, so here I first printed all of the column names from VA tract and also the census data. And you can see that we have the state keys common, county keys common, and then tract keys common. So now Here's the tricky part. You can just merge them probably based on tracks. But in that case, uh, some of those track number might be same for different counties. So there might be some mismatches. So instead of using only the tract number, you can use both county and tract number as common key and then merge them. So here I'm saying like calling the pandas library, then the merge function. Inside the parentheses, we have this Virginia DF, the census tract data, uh, serving as the left data, and then Virginia tract, the right side data, or like the geodata frame we just got, and left on is setting the primary keys for the left data, right on is setting the primary keys for the right side data, and we are saying we are going to do a inner join. Here, like after doing the join, you can see the data set I just got. Now, so this is a lot of columns. You can see that I have information about all the census tracts like male population, female population, all that, and then also the same like information from the right side data set as well. However, like to avoid all of this unnecessary information, we could just create a subset of columns which will be necessary for our case. You can do so by using this code. So here I'm just calling the data frame I just merged, VA merge, and then inside double square bracket, I'm putting the column names that will be necessary for rest of the analysis. So here I'm keeping the state FIPS, county FIPS, the tract FIPS, and then also the geo ID, total population, male population, female population, and also the final geometry. Now, you can apply additional functions, for example, summary statistics, creating new column, all in the same way as we did with other pandas data frame. For example, here I'm calculating the percentage of male population for each census tract, percentage of female population for each census tract, and like you can see the informations here. We can also perform group by function and estimate average male population percentage by counties. So here I'm saying like group this data set based on county FIPS and then calculate the average for all male population percentages based on those county FIPS. And here you can see the group by and the final output. So for county FIPS 001, the average male population percentage is 53.27%. And same goes for other information. Now, so last thing, like after doing all of this, how are you going to export? So after performing the pandas operations, for example, the merge, so the data becomes a pandas data frame, even though we have the geometry column in it. Here, like if you check the type of this merge data, you see like it's saying the pandas core data frame. Now, before exporting it as a shapefile, we first need to convert it back to the Geopandas object. And here you can do so with this line of code. And I'm calling the Geopandas library and then geodata frame, and I'm saying, okay, this VA underscore merge one, this one needs to be converted, and use this geometric column as the spatial information, and make sure you always provide the correct EPSG. Next, shapefile always comes with other additional files. So that's why first we need to create a folder so that we can save all of those files within the same folder. I'm using this exclamatory sign make dir, which is make directory, to create this new folder first. And once I create this new folder, I am exporting using the to file function. And so here I'm saying like, okay, save this VA merge one shapefile or geodata frame to this path within the collab directory. And once you run this code, you can just go to this files tab again and see that your shape file has been like exported to this particular folder you just created. All right, so that's it. And this is not everything about the geospatial data. We're going to learn a lot more about geospatial data, how to manipulate them, perform queries on them, and perform further analysis. So this was just a teaser how we can combine both spatial data sets and tabular data sets under using the Pandas and Geopandas library. So, all right, I'll see you all in the next lectures. Thank you so much.